everybody. I'm Shea from Flashbots, and today I want to talk about what I think is the most important problem in crypto. I think that if you kind of look under the hood, you'll realize that a lot of the challenges we're talking about in crypto today are actually all very related. Everything from execution quality to scaling to censorship resistance is all fundamentally downstream of one thing, which is how we approach something called MEV. And I'll say a little bit more about what that is in a minute, but MEV, in my view, is probably the most important factor to advancing the plot in crypto today, and possibly in traditional markets as well. So I want to show you why your biggest problems are actually MEV problems, and what this means we should actually be focusing our time on. I'm going to look at three things: creating new market structures, scaling them, and making them global, resilient, and fair. I think that these are some of the biggest challenges and opportunities for crypto, and under the hood, all of them are about MEV. Okay, so let's start with markets. I think probably one of the core values of public blockchains is that they give us a way to experiment with new market structures that drive better outcomes for people. So think about decentralized exchanges that reduce the friction of listing new assets. It takes 12 seconds, a few lines of code to launch a new Uniswap pool, compared to weeks of paperwork to list an asset on the New York Stock Exchange. Or what about permissionless lending and trading protocols where a whole market can compete to liquidate bad loans or give you a great price instead of just relying on a few wholesalers? In many ways, I think this is one TLDR of DeFi. Permissionlessness drives more innovation and competition, which results in better outcomes for people. But how do you actually get executed in crypto? What do these markets look like? I want to look under the hood for just a minute. One of the most popular things to do in crypto is to click this button, the swap button, exchanging one asset for another. It looks very simple, but what actually happens when you do this? What goes into getting a good price? Under the hood, it actually looks like this. So under the hood of DeFi is an economy of bots, tons of different actors that help with routing and merging and landing your trade on-chain. And there's also a lot of money changing hands here. There are incentives that apps and users pay these actors to perform, useful tasks, maybe even without your knowledge, incentives that we call maximum extractable value, or MEV. And there's also money flowing upstream in the form of things like better prices that this market produces for your trades. And you probably have no idea this is happening, but it is. Your favorite trading apps, CowSwap, Uniswap X, run auctions to outsource the execution of your trade to sophisticated parties like solvers or fillers who can solve the hard problem of finding you the best route, and they compete in an MEV auction to give you the best price. Your favorite lending protocols like Aave and Morpho offer permissionless bribes, aka MEV, to incentive bots who come and remove bad debt from the protocol. These MEV bots, again, participate in an off-chain auction to land their liquidation in the next block and capture those prizes. Your favorite wallets are actually privately auctioning off your order flow to improve your executions. For example, if you make a big trade, you will often create an arbitrage between the pool that you traded on and the price on other domains. So most Ethereum wallets today, a vast majority, actually send their users' trades to what we call an order flow auction, which lets a whole market of bots compete to backrun you, capture, for example, that arbitrage, and then split the profits with you. And again, the majority of retail flow on Ethereum today is executed through an order flow auction. TLDR, DeFi depends on MEV. At their core, all of these new protocols and market structures that we're experimenting with to give people better outcomes in crypto use MEV incentives to get very important jobs done, and also use permissionless auctions to harness all that competition for the MEV and turn it into things like better prices. Those MEV auctions affect everything from how your crypto wallets are executing your order flow, to the price you get on trades, to how healthy our lending markets are. And this actually could be relevant for more than crypto natives too. A few years ago, the SEC proposed a new rule, I think it's Rule 615, which would require retail trades in traditional markets to be routed through an auction. And for context here, in case you're not familiar, most retail trades today are executed privately by wholesalers like Citadel, who buy your trades from front ends like Robinhood in payment for order flow deals. And these PFOF deals can actually give users sort of better prices than the national average, the MBBO, but they aren't particularly competitive. So while users are getting a better price, they're not usually getting the best possible price. The SEC actually found a couple years ago that users were missing out on about 1 basis point per trade. So I think it comes to like $1.5 billion a year because of the lack of competition in PFOF markets. And the order flow auctions that we've been running for now years in crypto could actually be a pretty cool tool to help improve execution, not just for meme coin traders or crypto natives, but for retail participants in traditional markets as well. But all of these new market structures, again, depend on MEV. MEV, I think, is at the core of making DeFi work today and could be at the core of improving TradFi tomorrow. OK, now I want to look at a second challenge, which is how do we scale these great new markets? How do we onboard the world to crypto? Scaling is obviously a huge topic these days, especially for Ethereum. You know, L1 and L2 scaling are at the top of the new EF roadmap. Obviously, these things are also very important to teams and rollups building on Ethereum. And I think that these priorities are right, but I think that many people are misdiagnosing the root cause of our scaling problems today. And because of this, we're, I think, at risk of overlooking a key part of the solution, which is MEV. My golden rule of MEV is if you put free money on the internet, people are going to spam you for it. So if you offer permissionless bribes to bots, a lot of people are going to send you a lot of requests trying to win those prizes. And it can be worth it for MEV bots to pay for hundreds of failed transactions if they land just one that captures a juicy opportunity. And unfortunately, if you try to handle all of this competition on-chain, those failed transactions eat up tons of resources on your blockchain. This was a major problem on Ethereum L1 several years ago. So MEV bots were cluttering the chain to try to compete for opportunities in DeFi, which increased the gas price for regular people, raised the load on things like the P2P layer, and clogged up block space. So there's tons of failed transactions that now every node has to just re-execute in perpetuity. And the spam issue, actually, fun fact, was one of the inspirations for founding Flashbots. So the first product we launched back in, I think, 2020, like 5 years ago, was an auction called MEV that moved all this competition for MEV off-chain. But as Ethereum scales, as more economic activity moves on-chain, as rollup comes online, this actually just creates more opportunities for MEV, and so our spam problem grows. Today, sort of 5 years later, history is actually repeating itself. So we took a look at the data here, and spam transactions from MEV bots account for half of all the gas used on top Ethereum rollups today. There was, I think, one day where MEV bots were using something like 90% of the gas on Unichain, fun fact. And this rollup case is particularly notable because some of the unique properties of rollups. The spam is more intense. It has a kind of compounding effect on the rest of the ecosystem, and I think directly conflicts with some of the unique goals that we actually have for layer 2s. OK, why is the spam worse? Well, this is what a spam transaction looks like on L2. And if you are an Etherscan sleuth, you might notice something that seems kind of off, which is that this isn't doing anything. This transaction is quite literally not making any state changes on chain. It's just sort of paying gas to read some state. And we don't see this super often on L1 because the gas fees are expensive enough that it does not make sense financially to run your bot on chain. But it does on L2s for a number of reasons. One big one being that because the fees are so low, because gas is so cheap, searchers can basically afford to hammer every block with a bunch of speculative transactions. We've seen bots, I think, use something like 650 times more gas than they actually need to execute just one Uniswap v3 ARB. And creating more gas does not solve the problem. This winter base, I think, doubled their gas throughput. Pretty cool. It's like 15 to 30 megagas per second. But the problem is that the effective gas throughput for users stayed the same because almost all the new throughput was captured by spam. As we make gas cheaper, searchers just use more of it to express more complicated logic and run even more complicated strategies. I think you can't engineer your way out of this. The limiting factor, in my view, to scaling L2s today is not throughput. It's economics. It's MEV. And the other thing is that this sort of MEV problem on L2s, all this spam, well, it impacts the rest of the ecosystem too. All of these failed spam transactions, they take up blob space as rollups post DA to L1. And so we have to kind of pay for this not once, but twice. And I think this is just important to call out because everyone's talking about raising the blob limit. Well, L2s also need to invest in mitigating the spam on their chains. And I say the whole ecosystem because one rollup spam problem can impact not just the L1, but other rollups too. So when there are huge spikes in demand for blobs, the blob fee markets go haywire and create all of these headaches for people. So there have been some very funny episodes where airdrops on L2s cause these huge surges of demand for blobs on L1. And actually, I don't know if you can read this, but they made the blobs more expensive than call data, which is what the blobs were supposed to replace. And all this congestion can just take hours to clear. Okay, finally, last thing here is that spam really limits the kinds of applications we can build in crypto. I think one of the promises of rollups is to create so much capacity that fees approach zero for regular users. And the idea is in a world where users are mostly price insensitive, you can build many, many more novel use cases. I don't know, micropayments, agentic flows, on-chain social networks, right? But the spam from MEV searchers creates this persistent elevated base fee, not just for the bots, but for users too. And we really, really need to solve this problem if we want to onboard more kinds of applications to crypto. Okay, TLDR, scaling is an MEV problem, scaling L2s, scaling L1s, scaling the kinds of applications and markets that we can create. Fortunately, I actually do think there's a path forward here. We've run into this exact problem before. 5 years ago when we introduced off-chain MEV auctions to mitigate the externalities of spam on L1. And since then, more and more DeFi protocols have also started using off-chain MEV auctions to improve user execution, as we saw earlier. So I think we can, and it would be a very good idea if we kind of applied that same primitive, the off-chain MEV auction to layer 2s. Which brings me to the final challenge I want to talk about, which has to do with the core properties of public blockchains themselves. One, I think, theme you maybe have noticed or maybe picking up on throughout this talk is that we have actually been talking very little about what happens in the protocol. Because in an ideal world, MEV happens off-chain. There's an obvious scaling reason for this. We were just talking about if we want to prevent spam, we need to move the competition for MEV to off-chain auctions. And there's also an execution-based reason for this. So if somebody knows that you're making a trade, they can front-run you to make a profit and give you a worse price. So we really want to keep MEV-bearing transactions private before they get executed on-chain. But famously, public blockchains, not private. So if we want our MEV auctions to be privacy preserving, they need to be run on sort of different confidential infrastructure off-chain. Which means that for most people, a huge part of the experience of using public blockchains does not happen on public blockchains. If your transaction is MEV bearing, trades, liquidations, any really DeFi activity, most of your execution happens or is determined before your transaction reaches a validator. And the majority, as you can see, of transactions on Ethereum today, and actually for many years, are MEV bearing and go through these private channels. So I think that this means when we talk about the properties that we want Ethereum to have, properties like censorship resistance or neutrality, fault tolerance, permissionlessness, you can't actually just stop at the protocol. You really need to embed these properties in our off-chain MEV auctions. And there's actually probably a whole talk on each of those properties, but in the interest of time, I just want to talk about one that I think is really interesting. Arguably, one of the most important values that Ethereum has is censorship resistance. So we're trying to build a platform that can credibly and neutrally resolve competition between untrusting parties, say trading firms that don't really trust each other, or institutions in different countries that have different regulatory regimes and don't really have a shared system for resolving disputes. And a key part of making that work is making sure nobody can prevent somebody else from transacting. But in my view, most of the conversation around censorship resistance today is focused on what happens in the protocol. Designs like inclusion lists and fossil, while great, focus more on how proposers can ensure that every transaction lands on-chain. But that's not good enough, actually, for MEV. MEV transactions need to remain private, so a mechanism like Fossil, where you're focusing only on publicly known transactions, doesn't actually work. And the kinds of transactions that produce MEV, things like trading, are often very time sensitive. So actually most traders don't want to be included after a certain timestamp because it'll give them adverse selection as their prices move. And on top of this, there can be a massive incentive to censor MEV-bearing transactions, which I think is not really present in other cases. So imagine, for the sake of an example, imagine some MEV opportunity is worth 10 ETH. That means, actually, there is a 10 ETH incentive for somebody to censor the competition. Because if nobody else can bid for this opportunity, then you can basically pay almost nothing to win the auction by default and earn the 10 ETH. And this is really different, I think, from transactions that are doing something simple, like, I don't know, transferring some ETH from Tornado Cash. Sure, some nodes might have compliance policies that prevent them from processing those transactions, but that's really different from proactively competing and stopping a transaction from landing to go and capture MEV. All of this means, I think, we not only need a really different approach to censorship resistance for off-chain markets, which are more private and fast by nature, but actually we need a stronger form of censorship resistance that can handle the sort of adversarial behavior that specifically exists in MEV. Okay, so these are some of the properties that I personally think we should be talking about more, and I want to nerd snipe you to start thinking about them. First of all, how do we make not just the settlement and execution layer, but the networking layer censorship resistant? So can we do things like anonymize traffic, so it's impossible to selectively censor bids in an auction? Second, how do we raise the economic cost of censorship? What would it look like to maximize the number of auctioneers and architecturally decentralize our MEV markets so that the cost of censoring bids in the auction is much higher? Because now you have to bribe many, many more people to ignore your competitors. And third, how do we distribute these auctions around the world so that faults or preferences in one region don't create an advantage or a risk for the rest of the system? And is it actually possible, fun question, is it possible to do this, to geo-distribute our infrastructure for MEV in a way that also meets the latency requirements of MEV use cases? I think these are all really interesting questions. I would argue that an Ethereum without these things, an Ethereum that only works for slow, low-value public transactions, is not actually living up to its goals. But on the flip side, if we can create these fast, confidential, uncensorable global markets for MEV, that's a really, really powerful tool to help kind of advance the vision I think we have for Ethereum. So the TLDR, though, is we have to solve for these things in MEV, in our off-chain markets, if we want the majority of crypto users to actually benefit from them. Because under the hood, MEV markets are what make DeFi work, what make it possible to scale public blockchains, and where I personally think that the strongest forms of censorship, resistance, and other properties that we care about will actually originate from. Those are obviously very hard problems. I'm pretty optimistic personally that we can solve them, and I hope that you will join our collective of researchers and developers working on these problems today. Thanks.